Good afternoon, everyone. My name is Andrea Franza, and I've been working with Sinan, Marco, and Mats on the development of a routine design tool for the prediction of tunneling-induced structural deformation. In urban areas, when there is a tunnel excavation, there is the propagation of ground movements up to the surface that are likely to deform and potentially damage structures. Engineers have tools to reliably predict the deformation when structures are perfectly transverse to the tunnel axis at 90 degrees angle, whereas there is less of an understanding of what's the actual impact of the building skew on the soil structure interaction, as well as there is less of an understanding of the impact of the tunnel advancements and what's the actual soil structure interaction when the tunnel head is beneath the structure rather than past after the completion of the work. An important parameter to assess the soil structure interaction is the modification factor M, that is defined as the ratio between building deformation and greenfield deformation, and tells us if a structure is fully flexible and there is potential for distortions, or if it's going to respond as a rigid body to deformation. The tool has been set up by combining within an elasto continuum-based solutions a 3D analytical displacement field representing the input from tunneling, all together with the limiting tensile strain method proposed by Professor Barland to assess the maximum tensile strain within the structure that is related to damage. Validation has been firstly carried out in the case of a perfect transverse structure and final tunnel construction, and there has been a good achievement has been reached for our solutions with more complex numerical modeling. In addition, we have been looking at the variation of the modification factor with relative soil structure stiffness, and proposed solution plotted with red markers compares well with the empirical design method proposed by Professor Meyer from field data and previous investigations. And this made us fairly confident that this simple tool was useful to also look at the effects of building skew and tunnel advancements. We started looking into some data from an historical case study, Modic Street buildings that were 3-story brick structures affected by 2 tunnel advancements, and they had a different angle inclination with respect to the tunnel structure. We tried to validate our model looking at measured settlements of those structures that are reported as markers in the plotted, and comparing them with our prediction as solid lines for the 2 different facades that have different colors, as well as we looked into the variation of the maximum tensile strain within our structures as the tunnel progressed, and we actually started to also have some information on the soil structure interaction. And interestingly, we started to see that the most critical state for structure whose inclination is similar to the tunnel longitudinal axis is during tunnel advancements. And we are now moving into looking into the modification factor, how it's affected by tunnel advancements. But we actually realized that what we need is further field data, more accurate field data, because tunnel movements during tunnel advancements are not as great as when the tunnel is complete. And that's why in the following presentation, Marco is going to tell you more about some of the ongoing work at some very subchurch. Thank you very much.